everyone. In this session, we are going to discuss a module 5 linear algebra. So, in that the next topic is solution of the system of linear equation by iterative method. So, we are going to solve the system of linear equation by a trial method or a iterative method, and we name that method as Gauss-Seidel method. Okay. So, let me consider a system of linear equations. Consider a system of linear equation like A11x plus A12y plus A13z equal to B1 A21x plus A22y plus A23z equal to B2 and A31x plus A32y plus A33z equal to B3. So, this is the system of linear equations, okay, and we know how to solve this system of linear equation using a Gauss elimination method and Gauss Jordan method. Now, why we are going to apply Gauss-Seidel method, or when we are going to use Gauss-Seidel method? Yes, when we have numerically larger coefficients are along the principal diagonal of the coefficient matrix A, then we are going to use Gauss-Seidel method. So, Gauss-Seidel method is applied, or we are going to solve the system of linear equation by Gauss-Seidel method if they specify to solve you, or otherwise one more thing is when we have a numerically larger coefficients along the principal diagonal of the coefficient matrix A, and that we know we can represent this matrix or the system of linear equation in a matrix form, and that will be a coefficient matrix, right. So, let me write that. So, this can be replaced by Ax equal to B, right. So, if I write the matrix like this: A11, A12, A13, A21, A22, A23, A31, A32 and A33 is the coefficient matrix A, and matrix X is given by X, Y, Z and is equal to B1, B2 and B3 matrix B. So, when we have a numerically larger coefficients along the principal diagonal, then we are going to use Gauss-Seidel method. Okay. So, to solve this system of linear equation, we have a standard formula, that is by Gauss-Seidel method we have the formula like xr plus 1 is equal to 1 by A11 into B1 minus A12y minus A13z, and yr plus 1 is given by 1 by A22 into B2 minus A22 A21 xr, this will be yr and zr, xr plus 1 minus A23 zr, and zr plus 1 is given by 1 by A33 diagonal dominant elements and B3 minus A31 xr plus 1 minus A32 yr plus 1, and we assume the initial condition x naught and y naught and z naught equal to 0, and also here where r is given by 0, 1, 2, 3 etc., that is the number of trials, and the initial value will be 0. In every problem we are going to assume the initial condition as x naught and y naught, z naught value as 0. Now, what is the formula? xr plus 1 is 1 by A11, which is a diagonally dominant element A11 into B1 minus A12 yr minus zr. then yr plus 1 is 1 by a22 b2 minus a21 into xr plus 1. So here we are going to get xr plus 1, right. So we should use this value here, right, minus a23 into zr, which is the initial value, and zr plus 1 is given by 1 by a33 into b3 minus a31 xr plus 1, that was solved in the first step, minus a32 into y r plus 1, that is solved in the second step. This result is going to use here. Okay. So this is the formula to get the solution of the system of linear equation. Of course, you know the solution of system of linear equation means we are going to find what is x, y and z values, right. So now let us solve the problems. So the first problem is solve by Gauss-Seidel method, right, and the given system of linear equation is 20x plus y minus 2z equal to 17 and 3x plus 20y minus z equal to minus 18, 2x minus 3y plus 20z equal to 25. So before going to solve using Gauss-Seidel method, of course we should check whether the diagonal elements are dominant, that means compared to the other two coefficients of x, y, z. If I come to the first equation, if I compare with the y and z coefficient, x coefficient must be greater. If I come to the second equation, if I compare with the coefficient of x and y, x and z of course, the y coefficient must be more than the other two. And if I come to the third equation, coefficient of z should be more than the coefficient of x and y. Yes, we have. So we have coefficient of x as 20 here and coefficient of y is 20. Coefficient of z in the third equation is 20. Yes, we have the system of equation with the diagonally dominant elements of the coefficient matrix A. So I can solve using Gauss-Seidel method, right. So now let me construct the equation or the formula xr plus 1, yr plus 1 and zr plus 1. So with that, consider or let the initial values x0 and y0 and z0 as 0. So xr plus 1 is given by xr plus 1 equal to diagonal dominant element 1 by 20 into 17, that is the RHS value, minus the coefficient of y, that is 1 times of y r, okay, minus the coefficient of z, because we have here already minus sign, so that it becomes plus 2 times of zr. This is your equation xr plus 1. Similarly, yr plus 1 is 1 by 20 again into minus 18 minus the coefficient of x is 3 into xr plus 1 plus or minus, since I have minus here, that become plus 1 times of zr, that is the y value, and the last one is zr plus 1 is, again we have a dominant element 20, so 1 by 20 into RHS value 25 minus x coefficient is 2 times of xr plus 1 and the y coefficient is minus 3, so that minus of minus become plus 3 times of y r plus 1 is the z value or zr plus 1 result, where your r values are, where r varies from 0, 1, 2, 3 etc. And of course they given you to carry out 3 iterations. You can solve the system of linear equation using this formula, and also we can easily simplify if I construct the table. So I construct in this order. So the first column stands for a trial or iteration. The second column will be xr plus 1 value, that is nothing but x value. The third column y, and the next one is a z column. So if I put r equal to 0, in the first trial we should substitute r equal to 0, so that I will get the x1 value, because 0 plus 1 will be 1, so that I will get x1 value. And if I substitute here y r nothing but y0 and z r nothing but z0 has 0, then I left with 17 by 20 is nothing but 0.85. x1 value 0.85. Similarly, if I put r equal to 0 here, we will get y1. y1 is nothing but, I will write here 1 by 20 into minus 18 minus 3 into this result. If I put x equal to r equal to 0 there, so that I will get here x1. So, x1 value 0.85 minus or plus z0 is 0. R value 0, so z0 is 0. If I simplify that, we will get y1 as y1 equal to minus 1.0275. y1 value minus 1.0275. Similarly, if I put r equal to 0 here, z1 is 1 by 20 into 25 minus 2 times of 0.85. If I put r equal to 0, I will get x1. So, as I told you, I should use x1 there and y1 value here, so that plus 3 times of y1 is minus 1.0275. If I apply that or if I substitute that, your z1 will be 1.0109. So, this will be our first trial with r equal to 0. Right. Now, we are supposed to do 2 more steps, that is a 2 more trial. With r equal to 1, I will get 1 plus 1 as 2. If I substitute r equal to 1, then 1 by 20 into 17 minus y1, this result, plus 2 times of z1, that value. That should be substitute here, and if I divide and or if I add and subtract and divide by 20, your x2 is 1.0025. Or I will write one more step like this. You can easily simplify 1 by 20 into 17 minus y1 plus 2 times of z1. Substitute that value using your calculator, calculate the value, so that you will get x2 as 1.0025. Similarly, y2 is 1 by 20 into minus 18 minus 3 times of x2 plus z1. R value 1, substitute, if I substitute r equal to 1, we have this, and if I substitute the corresponding values, that is x2 here and z1 that value, then your y2 will be minus 0.9998. Okay. Similarly, z2 is 1 by 20 into 25 minus 2 times of x2 plus 3 times of y2. So, you know what is y2 and you know what is x2. Substitute those values, so that your z2 will be 0.9998. Right. So, that completes our second trial. Next and last trial is, if I put r equal to 2, then I will get x3 as 1 by 20 into 17 minus y2 plus 2 times of z2. You know what is y2 and z2, substitute those values, then we will get x3 as 0.9999, 4 times 9. Similarly, y3 is 1 by 20 into minus 18 minus 3 times of x3 plus z2. Then we will get y3 as minus 0.999, 4 times 9 again, and the last value z3 is 1 by 20 into 25 minus 2 times of x3 plus 3 times of y3. So, that z3 is 1.000. So, this is our solution of system of linear equation by Gauss-Seidel method. So, of course, I can conclude the result. Therefore, our x equal to 0.999, you can keep as it is, or you can write approximately, it is nothing but 1, right, and y is minus 0.999, it is approximately equal to minus 1, and of course, our z is 1. Of course, we can solve the same system of linear equation directly using a calculator. If you calculate, you can verify your result, right. you can cross check with your solution whether our x and y and z values are correct, and that you know how to calculate using calculator. Okay. Our next problem is, we are supposed to solve the system of linear equation, again of course by Gauss-Seidel method, but we have to carry out 4 iterations. Now the first thing is, we should check whether the system of linear equations are diagonally dominant. So the first equation, the x coefficient should be greater than the other 2 coefficient. If I compare with the other 2, x should be more than the y and z coefficient. If we have x coefficient as more than the other 2, the next equation, y should be more than the other 2, but here our z coefficient is more compared to the other 2. And in the next equation, yes, y coefficient is more compared to the x and z coefficient. If this is the case, then we can interchange the equation. If they given you in this order, don't solve keeping as it is, right? So we should rearrange the equation so that in the first equation x coefficient should be more, that means it should be diagonally dominant equation. So I am going to interchange the second and third equation. I will rewrite the equations like this: 5x plus 2y plus z equal to 12. Then I write the third equation as the second equation: 4y plus 2z equal to 15, and the second as x plus 2y plus 5z equal to 20 as the third equation. Now in the first equation, the coefficient of x is more, in the second y is more, in the third the coefficient of z is more compared to x and y. So this should be the order you should check before going to solve using a Gauss-Seidel method. Okay. Now with as usual method, construct your x, y, z formula, that is xr plus 1 equal to 1 by the diagonal dominant element 1 by 5 into 12 minus 2 times of yr minus the coefficient of z is 1 times of zr. The next equation, yr plus 1 is 1 by 4 into 15 minus 1 times of xr plus 1 into x is nothing but x, r plus 1 minus 2 times of zr. And the last one is zr plus 1 is 1 by 5 into 20 minus x, coefficient of x is 1, so xr plus 1, and y is 2 minus 2 times of yr plus 1, where we assume or we consider the initial conditions as x naught and y naught and z naught as 0. We know this, right? So we can solve the system of linear equation by constructing the table like this. Okay. So if I substitute r equal to 0 with the first trial, I will get the x1 value as 1 by 5 into 12 minus 2 times of y naught minus z naught, and if I calculate by substituting y naught z naught value as 0, your result will be 2.4. Okay. Similarly, r equal to or yr will be y1 1 by 4 into 15 minus x1 minus 2 times of z naught. If I substitute x1 value and z naught, we will get the y1 as 3.15. Similarly, z1 is 1 by 5 into 20 minus x1 minus 2 times of y1, and your z1 will be 2.26. So this will be our first trial. Okay. Similarly, if I put r equal to 1, we will get a second trial, that is x2 is 1 by 5 into 12 minus 2 times of y1 minus z1. We know what is y1 and z1. If we substitute and simplify using calculator, we will get x2 as our x2 is 0.688 and y2 is 1 by 4 into 15 minus x2 minus 2 times of z1, then y2 will be 2.448. and Z2 is 1 by 5 into 20 minus x2 minus 2 times of y2, then Z2 is given by 2.8848. This will be our second trial. And with r equal to 2, we have a third trial, that is x3 is 1 by 5 into 12 minus 2 y2 minus z2. If you substitute the corresponding y2 z2 value, your x3 will be 0.8451 and y3 is 1 by 4 times of 15 minus x2 x3, of course minus 2 times of z2, then y3 is 2.0972 and z3 is 1 by 5 into 20 minus x3 minus 2 times of y3, so that your z3 value is 2.9921. So this will be our third trial. Of course, we left with one more trial, that is r equal to 3. We will get x4 as 1 by 5 into 12 minus 2 times of y2 minus z2, z3 y3, of course we calculated y3 and z3, right. So that your x4 is 0.9627 and y3 is 1 by 4 into 15 minus x4 minus 2 times of z3 is given by y3, and y3, if I calculate using x4 and y3 value, z3 value, our y4, of course not y3, yes of course it is y4, y4 is 2.0013 and the last one z4 is 1 by 5 into 20 minus x4 minus 2 times of y4, so that z4 is 3.0069. So we solved or we carry out with the 4 trials or 4 iterations. Therefore, your x equal to 0.9627, you can keep as it is, as I told you in the previous problem, or we can make it as approximately equal to 1, and y equal to 2.0013 approximately equal to 2, and z is 3.00, yes of course this is 3.0069 is approximately 3. So the solution of the given system of linear equation is 1, 2, 3. So of course in the last problem I told you to verify with your calculator, that means you can check using your calculator or you can solve the system of linear equation using your calculator, or we can check in another method. If I put x, y and z value in any one of the equation, you should get the RHS value. For example, you know that x equal to 1, y equal to 2 and z equal to 3, right. So if I put here x equal to some number, so this is the verification part, you can verify here itself, okay. If I put x equal to 1, 5 into 1 5 plus y equal to 2, so that 2 2s are 4 plus z equal to 3, so we have 3. So 5 plus 4, 9, 9 plus 3 equal to 12, so your answer is correct. So what you calculated as x, y, z as 1, 2, 3 approximately, that answer is correct, because if I substitute that value with any one of the equation, you should verify with the result. Of course, if you substitute for the other two equation, you will get the RHS part. So this is the method of verification, what you got your result as x, y, z. Okay. Next problem is solve the system of or solve by Gauss-Seidel method. The equation is 5x minus y equal to 9, x minus 5y plus z equal to minus 4, y minus 5z equal to 6. Of course, we have to carry out a 3 trial or 3 iterations. Now, the first step, yes, we know that we should check whether it is diagonally dominant system. So in the first equation, the coefficient of x should be more compared to the coefficient of y and z. Yes, it is more. The next thing, we have minus 5 plus 1 and plus z, right. So we are going to consider only the numerical value, not along with the sign. So it is not minus 5, you should consider only the numerical value. So it is a 5. In the second equation, the coefficient of y is 5, or the diagonal dominant element is 5, compared to the other two it is more. Yes, the equation is correct, second equation. Third equation, I do not have x, I have only y and z. Of course, in the y or in the last equation, the coefficient of z is more compared to x and y. So the given system is diagonally dominant. So I can construct the formula so that xr plus 1 is 1 by dominant element is 5, 1 by 5 into RHS value 9 minus y value, of course we have minus there, so that minus of minus become plus yr, and we do not have a z coefficient, so it is 0. No need to write that has 0 because z coefficient is 0. Then yr plus 1 is 1 by 5 minus 4 minus the coefficient of x is 1. So 1 times of xr plus 1 and minus z coefficient 1, so minus zr. And the last equation zr plus 1 is 1 by 5 into 6 minus coefficient of x, we do not have x, right, so it is 0, and the coefficient of y is 1, so 1 times of y r plus 1. So this will be your equation. So the equations are of x and y, z are ready, or the formula of to find x, y, z is ready. So I can construct the table now. Yes, our table is ready. Now let me substitute the trials with r equal to 0, 1, 2, 3. So if I put r equal to 0, and of course I have to consider the initial condition, right? Let x naught, y naught and z naught, that will be same in all the problems, it is 0. So if I put r equal to 0, we are going to get x1. x1 is 1 by 5 into 9 minus, of course this is yr, in this step it become y naught, right. So y naught, we know y naught is 0, so that 9 by 5, so your x1 is 9 by 5 value 1.8, and y1 is 1 by 5 into minus 4 minus x1 minus z naught. So that y1 is, if I put a corresponding x1 and z naught value, what is our y1? y1 is 1.16, and the last one z1 is 1 by 5 into 6 minus y1. So that if I put corresponding y1 and if I calculate our z1 value minus 0.968. So that completes our first trial. Then the second trial is r equal to 1. So that x2 is 1 by 5 into 9 plus y1. So you already calculated y1, right? So use that y1 and substitute and simplify, so that I will get x2 as 2.032, and y2 is 1 by 5 into minus 4 minus x2 minus z1. So if I put x2 and z1 value, then I will get y2 as 1.0128. Similarly, z2 is 1 by 5 into 6 minus y2, so that z2 is minus 0.9974. So that's our second trial. Okay, and the last trial r equal to 2, so that x3 is 1 by 5 into 9 plus y2. You know what is y2, right? Substitute that, so that I will get x3 as 2.0026. Okay, and then y3 1 by 5 into minus 4 minus x3 minus z2, so that y3 is 1.0010. Okay, the last one, the next one is z3 1 by 5 into 6 minus y3. So if I substitute corresponding y3 value, then I will get z3 as z3 equal to minus 0.9998. So that completes our required trials. Now what is the required result? Therefore your x is 2.0026. So I can write approximately 2. Then y is equal to 1.0010, approximately yes 1, and z value minus 0.998, approximately minus 1. Therefore your x is 2, y equal to 1 and z equal to minus 1 is the solution of the given system of linear equation. Of course, you can check or you can verify your result using calculator by solving the same given system of linear equation, or else I can verify your result without calculator, that is if I put x, y and z value in any one of the given equation, I should get the same result as we have in RHS. So if I substitute in the last equation, we have y equal to 1 and z equal to minus 1, right. So I will substitute in the last equation, that is verification part. Consider y minus 5z, that is equal to 6, right. So y is 1 and z is minus 1, so we have 6. Yes, what you calculated using a Gauss-Seidel method, or what you get the solution using Gauss-Seidel method is correct. Your solution is x equal to 2, y equal to 1, z equal to minus 1. Thank you.